your notes as domains of rational expressions. Domains of rational expressions. Sounds horrible, but it's not. But the first thing we need to do is I want to take you back to middle school for a minute and talk about fractions. Because any number that can be written as a fraction is a rational number. So for example, 3 over 2 is rational.
Yeah.
What about 7 over 12? It's a fraction. Is it rational? Yes. It's a fraction, right? Fractions are rational. What about pi? Is pi rational?
No.
Can I write pi as a fraction?
Actually,
You cannot write pi as a fraction. Therefore, pi is not considered a rational number. We would call it, what do we call it? If it's not rational, we call it irrational. Yeah. What about this? What about 4 divided by 0? What is 4 divided by 0?
0.
It's 0?
Well, it's unsolvable.
It's unsolvable. What do we call it when we have a situation
Error.
like this? We don't really say unsolvable. We call it error. On your calculator, it will say error. We call this an undefined answer. An undefined answer. And the reason it's undefined is because what you are doing is taking nothing and dividing it into something. How can you divide nothing into something? You can't. So that's why we call it undefined. So really, really important here is that you understand that in a fraction, you cannot ever have 0 in the bottom. On the bottom, you can't have 0, okay? So we're not going to talk about fractions forever because that's called middle school. We need to talk about high school mathematics, and we're going to talk about rational expressions in terms of polynomials. So an example of a rational polynomial is this. A rational polynomial example would be something like this. 4x minus 3 divided by x squared minus 7. Is there a polynomial on the top? Is there a polynomial on the bottom?
Yep.
Therefore, this is what we call a rational polynomial. It is a polynomial divided by a polynomial. Are you with me there? Yes?
yes.
All right, so what we're going to do is talk about how you cannot ever have 0 on the bottom of a fraction. So what we're going to do is figure out what values of x would make the bottom of this fraction 0. Because we know that whatever we come up with for that value of x, the x value can't be that value. And you're probably thinking, what is she talking about right now? And I will clear that up in just a minute. So let's keep going. Let's go on to an example. An example. What if you have a situation like this? You've got 2x plus 3 divided by x minus 4. It's a rational expression. We have a polynomial divided by a polynomial. What did we say the bottom of this fraction cannot be?
0.
It can't be 0. Ignore the numerators today. We do not care about the numerators, okay? We will care about the numerators later, but not today. Today we are only going to look at the denominator. What value could I put in for x that would make this fraction have a 0 on the bottom?
4.
If I put in a positive 4. If I put in a 4 there, I would have 4 minus 4 on the bottom, which would get me 0. Can I have 0 on the bottom?
No.
You cannot. So this is what you're going to say. You're going to tell me that the domain of that rational expression is that x cannot be 4. So rather than telling me all the x's that do work, what you're going to do instead is tell me the x values that don't work. It's easier to tell me what doesn't work than to tell me what does work, because many values work. There's only usually a value or two that does not work. Does that make sense? Tell me what doesn't work rather than tell me what does work. Another example. Let's say you've got 2x squared minus 4x plus 1 on the top, all divided by, on the bottom you have x plus 7. Ignore the numerator. What's the domain? We're only looking at the denominator. Domain means what works. What values of x will make this a defined expression? Well, rather than telling me every single x that would work, tell me the one value that doesn't work. What is the one value that does not work? Go ahead, Charlotte. Negative 7. So you're going to say x cannot be negative 7. Yeah? Make sense? Not that bad. What am I really doing, you guys?
Making it where opposite side of the same.
Yes. What's it called when we do that? We take the opposite of x plus 7, we say it's negative 7. What is that called?
Zero?
You're finding the zeros of the denominator. Right? If I asked you what's the 0 of x plus 7, what do you tell me?
Negative 7.
You tell me negative 7. So what are the zeros of x plus 7? Well, negative 7. Therefore, when x is negative 7, a 0, we get 0 on the bottom. Another example. Another page. Example.
Let's just put EX.
Oh, of course. What about x minus 5 over x? What about that one? That's a tricky one. What values of x could I put in for x on the bottom that would get me 0?
0.
0. Okay, so it wasn't so hard, right? Okay, so we have a domain of x can't be 0. Make sure you're using that symbol, that notation, the equal sign with the line through it. Because if you say equals, you understand that means something completely different, right? Equals 0 versus not equals 0, completely different. All right. Example, another one. This is a tricky one. Okay. X plus 2 on the top divided by on the bottom. Let's do x squared minus x squared minus x minus 20. X squared minus x minus 20.
So didn't you just put it on the top? What we're supposed to be doing on the bottom?
Nope. Ignore the numerators. Do not do anything with the numerators. We're only looking at the denominator.
Right.
What do I need to do to this?
Take away the 20?
Yeah,
Nope.
you can't do nothing.
Nope.
You just have to put it in.
What did I just teach you guys?
This.
To change.
Combine like terms.
Do we have any like terms? Can
No.
I add this x squared and x together? No, can't do that. They're not like terms. We just spent a whole day on it yesterday, in the beginning of today on it too. We have to factor. Whoever just said that. You have to factor. See, that's why I taught you factoring, because we're going to use it now. We have to factor this. But you know what? Look at, these are not bad, because we have a 1 in front of our x squared. We have an x in the middle, and what do we call that number at the end? A constant at the end. Factor it. Help me. We are looking for two numbers. These aren't the hard ones. These are the easier ones. What multiplies to give you negative 20? And when you add them together, they get you that negative 1 in the middle.
Negative 5 and 4.
Very good. Negative 5 and 4. So I'm going to say, okay, well, this really is equal to x plus 2 over x minus 5 times x plus 4. Did I change the value?
No.
I just made it look a little different. So what's my domain?
So it would be positive 5 and a negative 4?
X cannot be a positive 5. It also cannot be a negative 4. Very good. In other words, I have found the zeros of the bottom. The zeros are what get me 0. Negative 5, positive 5 gets me 0. Negative 4 gets me 0. You with me?
Is that mean, can we just put a D?
Are you feeling a little bit lazy today? Instead of writing, can you just take a nap today?
It's up to you.
Another example. Thank you. Another example. X on the top, and then on the bottom, let's do 3x minus 6.
2.
What'd you do?
You multiply a number and then you minus 6. You multiply by 3 and then minus 6 from that.
Okay.
3 times 3 equals 6.
Let's say it wasn't that easy though.
Alright.
What do these things have in common?
3.
A 3. So I want you to get used to factoring because sometimes you don't need to, and if you don't need to, I'm really okay with you not. But if there's a time when you do need to, I want you to know how to do it. So what do these have in common? What do a 3 and a 6 have in common? A 3. I factor a 3 out. And when I factor a 3 out of 3x, what am I left with?
0.
X
X.
minus 2.
Just an x. And when I divide it out of 6, I have a minus 2. Alright, so what's my domain?
Positive 2.
X cannot be, what can it not be?
Positive
It
2.
can't be positive 2. What about that 3? What do I do with that?
Negative 3.
Does it have an x with it?
No.
It's just it's alone. It's just a 3. So that tells you nothing. That is not going to change your domain. There's only one issue in our domain, and that is when x is 2. So anything will work except for 2. The 3 does nothing. Another example. Can someone grab the door for me, please? Thank you. All right. Let's say we've got 3x on the top. And then on the bottom, let's do 3x plus 1 on the top. And then on the bottom, we have 2x to the power of 2 minus 4. Think factors, 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 factors.
Get 2 over 2.
Okay, so I've got a 3x plus 1. Hey guys, can I add an x to that? Please put an x next to your 4, make it minus 4x instead. What do these have in common?
X.
X.
2x.
They're all both divisible by 2, they're both divisible by
X.
x. So I take a 2x out. Okay, so if I divided 2x out of this is just scratch work I'm doing here right now. What is 2x squared divided by 2x?
X.
Those cancel out. You are left with x. What is 4x divided by 2x?
2.
Those cancel out. You have a minus 2. What's your domain?
Positive 2.
X can't be a positive 2. Yeah, and then we have 2 times x. There's nothing added or subtracted with it. What? So if I look at this alone, what could I put in for that x value that would make 2x equal to 0? 0. So x can't be 2 and it can't be 0. There's your domain. So in other words, whenever you have x all alone, with nothing added or subtracted to it, when I say alone, I mean added or subtracted to it, then your domain is going to be that it can't be 0. All right, I have one more example, and then I'm going to stop talking, and you guys can have the rest of the hour, all 2 minutes of it. So nice, huh? All right, your example. Let's just put a number on the top. Put a 5 there. And then on the bottom, let's do x squared minus 16. Now, in the past, every single year, a situation like this shows up on the test, on the unit test. And I have more people do it wrong than I have do it right. And I don't know what I can do different to make you do better when you see a situation like this. So I'm going to start right now, and we will talk about this over and over and over again. What kind of number is 16?
Perfect
It is
square.
a perfect square. So this is a very special factoring situation. We have a perfect square. What about x squared? What is that?
Perfect square.
It is also a perfect square. So what we have here is a perfect square minus a perfect square. This is called a difference of squares. So when you have a minus sign in between 2 perfect squares, this is what you get. 5 divided by you take the square root of x. What's the square root of x? X. So you put an x here, you put an x here. What is the square root of 16?
4.
4. So I put a 4 here and a 4 here. One of them is plus, one of them is minus. Good. So if I asked you for the domain, in this case, you would say that the domain is that x cannot be what? 4 or negative 4. And you can write it like this if you want. You can say, okay, it can't be positive, can't be negative 4. Plus or minus 4. Alright? Okay, let's piggyback off of that. What's x squared minus 25?
X can't be 5 or negative 5.
Perfect square. Perfect square. So what did you say it was?
Can't be negative 5 or 5.
Okay, well, I'm just talking about in terms of factoring it. You would get x plus 5 and x minus 5. So then if I asked you for the domain, only if this was the denominator, you would say, okay, well, x cannot be negative 5, it cannot be 5. What about this? X squared minus 121.
11.
11 is the square root of 121. So when you factor this, you get x plus 11